Alright, so here we've got to first show the area of the segment. Let's look at the area of the segment, coloured in blue. We know that that area is equal to the area of the sector minus the area of the triangle. Now the area of the sector, you know, it's 2 theta out of a whole round, so 2 pi, of the circle, area of a circle, which is pi r squared. And the area of the triangle using half AB sine C. So A and B are both R. We've got R there and R there. So AB is R squared. Sine of the angle is 2 theta. So if we simplify that, the 2 cancels, the pi cancels. If I factorise by R squared, we have theta minus half sine 2 theta. Now we know that sine 2 theta is 2 sine theta cos theta. That's an identity that we use fairly often. So we can change that to theta minus, so 2 times a half is 1, so we just get sine theta cos theta. There. Alright. If I just have a look at this triangle here, so that triangle there, where we just have 1 theta, this is x and this is r. You can see using Pythagoras that this other third side will be r squared minus x squared, and that might come in handy for a question. Alright, if we have a look at what we're supposed to do, explain this. Well, if we're finding dA to t, we can use multiple derivatives to find it, and we can use this because the d theta cancels, the dx cancels, and we get back to dA to t. So that's fine, we can use that, no problem. Let's show that d theta dx equals negative blah blah blah. Alright, so basically if we're looking for a d theta dx, we need an equation that has theta and x in it. So looking in this triangle that we just drew, we know that cos theta equals x on r. We do. And that means x is r cos theta. So I could dx to theta now because I've got an equation that links x and theta, and then I can tip it upside down. So dx to theta would be minus r sine theta, cos theta goes to negative sine theta. And if I tip that upside down, I'm going to get negative 1 on r sine theta. Now if I want that in terms of x's and r's instead of sine theta, let's just go back to this triangle. And what is sine theta equal to? Some old tags. So I get the r squared minus x squared on r using this triangle here. So if I put that in here, I've got 1 on r, I might just do it like this, times, times the reciprocal of sine theta here. So the reciprocal will be r on square root of r squared minus x squared. So those r's will cancel, and I will just get negative 1 on that r squared minus x squared there, which is what they wanted us to get. Alright, so now we've actually got to find dA to theta. Now, dA to theta, so when r equals 2 and when x equals 1. So actually, if I put that right in here already, I'll just use a different pen so you can see where I'm writing. So I will know that d theta dx equals minus 1 on square root of r squared, so that's 4, minus x squared, so that's 1. So we've got negative 1 on root 3 for d theta dx. Okay, so if I go to my, so I'll rub that out now, I think. Well, that was my dx to theta, but anyway, that's fine, we can figure that out again. Alright, so I want to find, given that I find the increase in the area, so we are looking for dA to t, and we know that that comes from dA to theta, dA to theta times d theta dx. Oh look, d theta dx is that, oops, times dx to t. Dx to t, we've already got x, it tells us dx to t, so it is minus So you can see those two just cancel and make a positive 1. So really we're just after dA to theta. All right, and we have A in terms of theta. We originally got that at the beginning here. And let's write that out. So dA to theta was, let's look at A. So we had R squared. So I'm just going to put R squared theta minus, and we had half R squared cos, sine 2 theta. It's kind of easier, I think, in that form to differentiate. So dA to theta, I'm differentiating this with respect to theta. So I'm going to get R squared. That's that first term. And I'm going to get half of R squared. Now sine 2 theta will go to cos 2 theta times 2, chain rule. All right, but we know that R in this case is 2, so this is going to be 2 squared minus half of 2 squared, cos 2 theta, I'll do that in a sec, cos 2 theta times 2. So at the moment we've got 4, 1 minus cos 2 theta, because you've got that 2 times 2 is 4. What is cos 2 theta? Well, we know what cos theta is. If you remember back to that triangle, which had theta there, and x and r and square root r squared minus x squared. So we know that r is 2 and x is 1. There we go. And that's all we need for cos theta. So we know cos theta is a half. That means that theta is pi on 3, so cos 60 is a half. So if I double that angle, I am going to get 2 pi on 3. So I am in the second quadrant. So cos of 2 theta in the second quadrant is a negative half. So if I put negative half in there, I've got 4 lots of 1 minus a half, which is 1 plus a half, which is 3 on 2. So 4 lots of 3 on 2s is 6. So dA to theta, so the area will change with respect to theta, equals 6. That's the rate of increase in the area, is 6.